Okay, welcome back. This is part 3 of thermal processes, and this will be the last part of the chapter. In this part of the chapter, we'll be going through some of the applications of thermal processes. So let's go into it. We will see how we can apply the concept of conduction, convection, radiation in your everyday life. Okay, so the first one is an example of your hairdryer. Okay, so what happens in your hair dryer is there is a motor, and this motor will be pumping cold air through a heating element. Okay, there's a heating element over here. So as the air passes through the heating element, it is in contact with the heating element. It gains energy from the heating element via conduction. Okay, and the hot air then blows out of the hair dryer. Next one is your water heater. In your water heater, there is also heating element. The heating element is usually over here. Okay, so what happens here is the cold water goes in, it gets heated up by the heating element, and then which passes the energy again by conduction to the water. Okay, usually the heating elements is placed at the bottom, so the hot water will then rise, cold water then sink. Okay, so the whole water heater will get heated up, and then the water will move out of the water heater. Okay, next one, also by conduction, whenever we are feeling cold, we wear a jacket or we wear materials with down feathers and microfibers, especially in very cold countries. Why is it so? Because such materials will actually trap a lot of air in between them. And air, every time when we talk about air is a type of material, so air is a very poor conductor or very poor thermal conductor. So when you have a layer of air surrounding you, there is little heat transfer. Heat cannot pass through the air easily. So we say that air is a very poor thermal conductor, that it reduces the energy loss by conduction. And also when you have trapped air, remember, whenever there's trapped air, there will also be no convection current being formed. So it actually also helps to reduce energy loss by convection. Next, we also have applications of conduction via your double or triple glass windows. Okay, double glass windows are more expensive than a normal glass window because it's actually made out of 2 layers of glass. So you can see over here, this is triple glass, this is double glass. Double glass are usually good enough already. So there is 2 layers. In between them is a very thin layer of air. So it actually traps a layer of air in between them. So again, like what I mentioned, air is a poor thermal conductor. It reduces energy loss or energy transferred by conduction. It also reduces energy transferred by convection because the air is being trapped over there. Okay, so usually for energy efficient buildings, they are designed with double glazed windows, okay, to minimize the energy transfer between the surrounding, the outside of the shopping mall and the inside of the building. Okay, next, for convection, we have your kettles, we have your aircon. Okay, so for your kettle, we know that the heating element is always placed at the bottom. Okay, so convection is always about position. So if I place my heating element at the bottom, my hot water that is near the heating element will first gain energy by conduction because it's in contact with the heating element. And then so the water at the bottom will expand, becomes less dense, and then it will rise up. And the water at the top will then be denser and sinks and set up a convection current. And eventually the whole pot of water that is even at the top that is not in contact with the heating element will get heated up. Next, hot air balloons. Hot air balloons also work by convection. So you have a fire at the bottom, the burner at the bottom. The burner will burn or will heat up the air, okay? And this hot air will then rise. And then the cold air in the hot air balloon will then sink down, be heated up again. So this ensures that the air inside the hot air balloon will always be hot, okay? When the air inside the hot air balloon is hot, it will be less dense than the surrounding, and therefore it will move up. And then when we do not want it to move up anymore, we can switch off the burner so that the air starts to cool down. And when it starts to cool down, it becomes denser. Once it's denser than the surrounding air, it will sink. Okay, so if you do not want it to sink, you need to on and off your Bunsen burner or your burner, not Bunsen burner. Next, application of convection. We also have a land breeze and sea breeze. You need to know that in the day, if you go to a swimming pool, you'll feel that the swimming pool is very shook. Okay, the water is very cold. So in the day, the land is hotter than the sea. So the air above the land will rise. Okay, the air above the sea will sink because it's cooler. And then this will result in a convection current. Okay, a natural convection current, which we call it your sea breeze, because the air is going from the sea towards the land. It's called a sea breeze. Okay, but at night the opposite will happen. At night the land cools down faster than the sea. Okay, so if you were to go swimming at night, you will realize that the water is slightly warmer. So the hot air above the sea will rise, the cold air above the land will sink, and now I'll form a convection current that move in this way. So it's called a land breeze because the wind is moving out of the land, from the land towards the sea. It's called a land breeze. Next, radiation. We have something called a space blanket. A space blanket looks like this. It's very shiny, very silvery. Okay, so it has a very shiny and smooth surface. Where is it used? It's usually used in situations where we need to keep a person warm or cold. Okay, we want to minimize heat transfer between a person and a surrounding. So we wrap the person up with this space blanket. Okay, because of it being a very shiny and smooth surface, it's a very poor emitter of infrared radiation. Okay, or it's a very poor absorber of infrared radiation. It cannot absorb a lot of heat. It cannot also emit a lot of heat. So if the person is feeling cold, then the person will not be able to emit out a lot of heat. So for example, it's used in emergency situation where a person falls into very cold water to prevent the body from losing too much energy. Then you just wrap the person up with this blanket. Okay, similarly, you can also wrap a house up with this blanket to protect the house against large-scale bushfire because it's a very poor absorber. So it doesn't absorb a lot of infrared radiation so that the house will not catch fire. Okay, next. Okay, then we move on into Singapore's context. Okay, our school is being repainted. Why is it being repainted? Because our school is one of the so-called project on how does school paints helps to reduce the temperature indoor. Okay, so our new paint is actually a cool paint. Okay, I'm not going to play this video, but you can read up on, or you can play this video at home to find out more about how does cool paint works. Okay, and then next we also have a few buildings in Singapore that is energy efficient. We want to minimize the heat transfer between the building and the surrounding. So we have your Gardens by the Bay. And then you can also read up on all these articles to research to find out about how conduction, convection, and radiation is being minimized in these buildings. Okay. Yes, that's it. That's the end of this chapter. And then I will move on into how do we answer questions for this start of for this chapter. So I'm going to share with you this. Okay, so over here you can see that I have a mind map over here. So I know that energy will always flow from a region of higher temperature or a region where it's hot to a region where it's cold or a region of lower temperature. It moves through by three different methods: conduction, convection, radiation. So conduction is always related to materials. And then in conduction, I always need to see the keyword: is a good thermal conductor or is a thermal insulator. And then for convection, it's always about position, and it only occurs for liquid and gas because solid particles cannot take the heat energy and move. So it only occurs for liquid and gas, which we call it a fluid. Okay, so keywords that I need to see in your answer keys is I always need to see the hot fluid expands or becomes less dense and rise, or the cooler fluid is denser and it sinks, setting up a convection current. Okay, or it can pass through by the process radiation, whereby I do not need any particles. For radiation, it can take place through a vacuum. I have no need of particles. So radiation is the emission of energy in the form of infrared radiation. So for radiation, I need to see any one of these keywords is either absorber, emitter, or a reflector, depending on the main function of the material. So what are the steps to answer thermal transfer questions? The first step, you always need to identify whether the object is gaining heat or losing heat. Okay, you need to determine the direction of heat flow, and remember the heat will always move from a region of high temperature to a region of lower temperature. And then we need to determine the process by whether is it the material that they are considering, the position that they are considering, or about the color, texture, surface area, or surface temperature that they are considering. So from that, we can deduce whether it's conduction, convection, radiation, and then use the keywords to explain your answers. So I'm going to go through a few examples. So the first question, explain why a saucepan is usually made of copper. So the keyword over here, I'm going to highlight for you. The keyword over here is copper. So copper is a material. So when I talk about material, I know that I must be talking about conduction. Okay, and then the first step is you need to determine the direction of heat flow. Saucepan is usually placed on top of fire. So the saucepan is gaining energy from the fire or from the stove. Okay, so the answer key, I need to see the word conductors or insulators. In this case, copper is a good thermal conductor. So I have the keyword thermal conductor. So what? Okay, I need the second part. There's always two parts to heat transfer questions. The second part, so it's a good thermal conductor. So what? I will be able to conduct a lot of heat, okay, easily through me to reach the food, okay, because copper is a good thermal conductor. A lot of energy can be conducted through it, or a lot of energy can pass through it by conduction, okay, either conducted through the saucepan or conducted into the saucepan, or energy can be passed through it by conduction. Okay, the second step must be written so the food can be cooked faster. Next one, explain why aircons are placed at the top near the ceiling. So the keyword is at the top. It's about position. So whenever we talk about position, immediately in your head, you must know that the process is convection. And then this is an aircon. There is no hot air involved. It blows out cold air. Okay, so over here, we will say that the hot air expands, becomes less dense and rise. It then gets absorbed into the aircon to be cooled down. And then the cooler air that comes out from the aircon is denser and it will sink. And this will set about a convection current. So the keywords are already all underlined. Next one, explain why solar panels are painted black. So the keyword over here is black. So whenever I'm talking about color, surface area, texture, I'm always talking about radiation. You need to know the process is radiation. Okay, then you need to think, oh, this is solar panels. The main function is it whether to absorb heat or emit heat. We seldom use the word reflectors. So we always consider absorbers and emitters first. So you should know that your solar panels are mainly to absorb heat. The main function is to absorb heat. So I want to see the keyword is an absorber of infrared radiation. I repeat again, we could not write absorber of radiation. It must be absorber of infrared radiation. So over this case, I would say black is a good absorber of infrared radiation. So what? Then again, the second step, more energy can be absorbed or more energy can be transferred to the solar panels by radiation. Okay, so the second part must be present also. So it's a good absorber, more energy can be absorbed. If it's a poor emitter, then less energy can be emitted. Okay, next one. Okay, why heating elements are placed at the bottom? So this is again about position. So it must be related to convection. So the answer is as follows. Again, water near the heating element will get heated up, expand, becomes less dense and rise. Cooler water at the top is denser and sink, and this will set a convection current. Again, the words in bold and red must be present for your marks to be there. Next one, explain why your feet feels colder on a marble floor than on a wooden floor. So in this case, I'm comparing marble and wooden. It's about materials. It must be related to conduction. So my question asks for on marble floor. Okay, so I want my answer on marble floor rather than on wooden floor. Okay, we know that wood must definitely be a poor thermal conductor. So in this case, the marble floor is a better thermal conductor. Okay, better isn't a good one, but it's better thermal conductor than a wooden floor. Okay, so that's the first part. So what is it? Okay, why is it better? Why your feet will feel colder? So it is a better thermal conductor. So what happens is more energy will be transferred from the feet. Your feet is warmer. Your body temperature is about 37 degrees. Your feet is warmer than the surrounding of about 32 degrees Celsius. So more energy will be transferred from the feet to the marble floor by conduction, or more energy will be conducted away from the feet, and therefore the feet feels colder. Next one, explain how polar bears keeps themselves warm. Okay, so polar bears, they did not mention about white color, so we do not assume that we know that polar bears are white in color, but we do know that polar bears have very thick furs. Okay, and or in fact, the question will tell you polar bears have very thick fur or is white in color. Okay, so in this case, I want to talk about the thick fur. Okay, anything thick fur, expanded polystyrene, they all traps air. Okay, so air, you know that it's a material. I need to see poor thermal conductor. And then I also need to see the second part. So what that is a poor thermal conductor? So less energy will be conducted away from the polar bear, or less energy can pass through the polar bear by conduction. Okay, so it will help to keep the polar bear warm. Next one, explain why it is warmer to be in the house painted white on a snowy night. Okay, so the keyword here is white color. Okay, so it must be related to radiation. So on a snowy night, you should know that the house is warmer than the surrounding. So in this case, the house is going to emit, okay, give out radiation. So I want to see the word is an emitter. So white color is a poor emitter of infrared radiation. So what? Okay, so that less energy will be emitted out because it's a poor emitter. Less energy will be emitted out of the house, keeping the house warmer, or less energy will be transferred by radiation, keeping the house warm. Okay, I have one more example over here. Okay, the question asks, you have this pack which contains frozen liquid. It's placed in a holder under the lid of a box. As shown, the box is then, this whole box is used to keep food cold. They ask you why the frozen pack is placed at the top of the box, not at the bottom. So I'm asking about position again. So this one, the cooler pack is cold. So I want to talk about the cold part first rather than the hot part. So you tell me when the cooler pack is at the top, the air near the cooler pack will cool down, becomes denser and sink. Okay, the warmer air at the surrounding at the bottom, which is less dense, will then rise up. And this will set out a convection current. Okay, so the keywords are all present over here. Next one, why does the food stays cold for a longer period of time if the wall is made of rigid plastic rather than steel? Okay, so I'm asking for about plastic. So don't go and describe about metal for me. So I know that I'm related to materials. I'm going to talk about conduction. So I'm going to talk about plastic, not metal. So plastic is a thermal insulator. So what? So because it's a poor thermal conductor, less energy will be transferred into or less energy will be conducted into the box. Okay, so this will help to keep the food cold. Okay, I will stop here.